Friends, in the last lecture, we have explained the variation of the specific conductance and equivalent conductance with respect to concentration or volume. In case of strong electrolyte, the specific conductance increases with concentration proportionally, but in weak electrolyte, the specific conductance increases with concentration but marginally. For equivalent conductance, does not decreases appreciably with concentration, but equivalent conductance decreases appreciably with concentration in the weak electrolyte. Therefore, specific conductance gives more effect in the strong electrolyte, and equivalent conductance gives more effect in the weak in case of weak electrolyte. Such a explanation are explained by the number of theory. The one of the famous theory, that is Arrhenius theory, but Arrhenius theory having some drawback, that is it is satisfactorily explain the variation of the conductance of weak electrolyte with concentration, but this theory is failed to explain the variation of the conductance of strong electrolyte with concentration. The another drawback of the Arrhenius theory, that Arrhenius assume each ion behave independently than other in the solution. It is again true for weak electrolyte, but it is not true for strong electrolyte, because in the strong electrolyte the cation or anion gives repulsion and cation gives attraction. Therefore, one of the famous theory which can be satisfactorily explain the variation of the equivalent conductance or specific conductance with concentration, and such a theory is developed by Debye, Hooker, Onsager, and it is called as Inter-ionic Attraction Theory. Friends, this theory based on the two effects. The first effect is called as asymmetric or relaxation effect. The second effect, that is called the electrophoretic effect. First, I will focus on the asymmetric, means relaxation effect. In strong electrolyte, the attractive force operates between the cation and anion, and repulsive force operates between the cation and anion. Therefore, cation is surrounded by opposite charge ion, that is anion, to give sphere, and anion is surrounded by opposite charge ion, that is a sphere of cation. Such an ion sphere is called as ionic atmosphere, and it is a gives force of attraction between the cation and anion by symmetrically. Therefore, distribution of the anion around the cation or distribution of cation around the anion is symmetrical. Such a symmetrical atmosphere is called symmetrically atmosphere. Friends, if electrical field is applied or in presence of electrical field, the ions move opposite charge electron, means cation move towards cathode and anions move towards anode. Therefore, ion in surrounded ionic atmosphere move in opposite direction. Therefore, their speed minimized to each other, and due to such a moment, the symmetrically distributed ion convert into asymmetrically ones, and ionic velocity decreases. So equivalent conductance is also decreases with concentration, and such effect is called as asymmetric effect. Now, friends, the reformation of symmetrical atmosphere, means relaxation effect, require some time, but it rarely occur, and it is not instantaneous process in presence of electrical field. Now, the second effect, that is called electrophoretic effect. Each ion in aqueous solution is hydrated. The ions move against solvent molecule associated with the opposite charge ions, means cation move the solvent molecule associated with anion and vice versa. Therefore, ionic mobility decreases the equivalent conductance, and such effect is called as electrophoretic effect. Friends, the cation surrounded the sphere of the anion and anion surround the sphere of the cation. But solar molecule is also move surrounding anions, and thus a solar molecule decreases speed of the anions, and hence equivalent conductance also decreases. Now, such a explanation are well done explained by Onsager equation. This equation is useful to explain the asymmetric or relaxation effect. Also useful to explain the electrophoretic as well as Brownian motion of the ions. It is also applicable for 1,1 as well as other electrolyte. But this equation having some drawback. The first drawback is it is not applicable for other than water solid molecule are used. The inter-ionic theory is satisfactorily applied for the dilute solution of the strong electrolyte, but not useful for the concentrated solution of that. Okay, thank you so much and take care.